All right, good afternoon, everyone. I hope you have been enjoying the event so far. We're getting into one of our keynote lectures, the very last one for the week, and that will lead to the von KARMAN Award for International Cooperation in Aeronautics. So this year, the award goes to the Aeroelastic Tailoring project, through which the Embraer and a consortium of top institutions worldwide have made groundbreaking advancements in aeroelasticity and MDO research, fostering international collaboration, cooperation, and driving transformative innovation in aeronautics. On behalf of this group of researchers, Pedro Cabral is going to be the speaker with us today. He's a principal research and development engineer at Embraer for San Jose dos Campos. And at the end of the presentation, we're going to take some questions, and then I'm going to come up and award him the von KARMAN Award, and it's this big, okay? So it's really something that your wife will have to have at home, okay? All right, very good. Please.
So, good afternoon, everyone in the ICAS community. Buon pomeriggio a tutti. 40 years ago, I was here in Firenze at this time of the year, at the end of my assignment in the AMX development program. It was my first international experience in cooperation. It was a successful cooperation program with Alenia, former Air Italia, Aeronautica Macchi, and Embraer. We learned a lot on this cooperation. Now we are back here in Firenze, and I have this privilege and honor to represent this great group of researchers here, and Embraer, telling the context and the footprint of the Aeroelastic Tailoring project. We have been working together in a different way, like Professor Erasmus said, a unique way. So, my lecture will present, outline the first phases of our project, the aeroelastic tailoring phases as well, our partnerships, main research topics, the research areas. I think the most important topic are the drivers in the cooperations, the Embraer benchmark models, and the project results from the academic point of view and from the Embraer, our conclusions, and we're going to have feedback from the researchers and the institutions. Okay. So, all started in February of 2012 in this project of the composite wing aeroelasticity, where we were addressing the key issues in the aeroelasticity of composite aircraft, touching the areas of composite modeling, model correlation and updating, uncertainties and variabilities in dynamics and aeroelasticity, with a lot of investigation studies. So, one of the main performed experiments were the ground vibration tests in a thermal chamber to study the effects of low and high temperature on composite assemblies. This chamber was built with the technology we have now in Embraer for the landing gear industry for endurance tests. One of our internal tests, most challenging internal tests. So, and with this project, Composite Wing Aeroelasticity project, we realized that the main challenges we have to face in the design of composite structures were the need of methodologies, processes that will allow us navigate their complex design space. It was also evident the importance to consider the implications of using composite structures from the beginning of the initial phases of design, opening the investigation with processes with multi-fidelity tools and models. There was also, still now, an increased interest of aeronautic industry in lightweight wings, bringing to the structure close to its stiffness limit with challenges related to aeroelasticity. And these processes, they exploit composite anisotropy. The classical, and with this, we envision the aeroelastic tailoring technology. The classical interpretation of aeroelastic tailoring, as pointed in the slide, is based as defined as a collection of processes that will exploit the composite anisotropy to delay aeroelastic instabilities with the minimum weight penalties. But we applied a wider view, broad view for aeroelastic tailoring, a multidisciplinary design to fit a structure in terms of strength, stiffness, considering stress, strain, buckling, and the aeroelastic stabilities to low weight and high performance. We should not view aeroelastic tailoring as just flutter tailoring, because with the other requirements, flutter optimization is not so useful. So we envisioned this project, and we organized the project in 2 phases. The first phase from 2015 to 2019, it was with the motivation to design more efficient aircraft with composite materials. The main objectives: study design methods for innovative aircraft and study optimization methods for design. Expand the partnerships, improve the relationships started in the Composite Wing Aeroelasticity program, and develop an R&D framework for aeroelastic tailoring, with the main goal to determine the main drivers of more efficient aircraft with this application of this technology. The second phase, that is finishing next year, we called with the acronym ATAD, Design Enabled by Aeroelastic Tailoring. And with this phase, we are consolidating the framework started in the first phase with a continuous improvement of the developed processes. The primary goal of keeping and continuing the network of partnerships and internal applications with knowledge dissemination. You're going to see that we had knowledge dissemination along all the project. These are the main research areas, main partners that participate on this. And when we touched aeroelastic tailoring in a broad scenario, like low fidelity, high multi-fidelity, aerodynamics and loads, steady and unsteady transonic aerodynamics, structures topics like global local multi-scale design. We started the considerations of variabilities and uncertainties, the robustness of the technology. We followed the verification and validation needs to our industry to change the position of a deterministic industry to a more stochastic industry. And all over the phases, we explored multidisciplinary tools. So, according to this, I think most of you know this paper, the Aeroelastic Tailoring of Transport Aircraft Wings, the State of Art, that was issued by NASA in 2014. During all this project, we touched the following areas: computational synthesis tools, global tailoring, local tailoring, and we explored some of the potential material and structural enabling technologies, like passive technologies, like reinforced core sandwich, fiber toe steering within the composite laminates, and non-conventional structural designs. So, what are the main cooperation drivers? These were the drivers that we had in mind, but they were built along the partnership as well with some novelties. So we always have had a small aeroelastic tailoring team of Embraer, of 3 to 4 engineers from our R&D department. Embraer is very well geared in terms of resources. So we had support and have support from different departments. And the important point, this small team was maintained during all phases. Another important value, the financial co-participation of Embraer and the institutions during all the activities, even organizing our workshops. I truly believe in diversity. Diversity of ideas, solutions, academia backgrounds, cultures, they make a difference and you can get great ideas, as Bob Pierce told this morning. We have great ideas from diversity. And we can practice our cultural intelligence, the ability to work and create relationships in culturally diverse situations. These are the institutions, a team of researchers, around 35 during all phases in the project from 13 institutions. These are the institutions, and we have support from other institutions, like from other R&D initiatives in Embraer as well, like the MDO lab from the University of Michigan, and with its collaboration with NASA in the development of MDA, Open MDAO. So another important driver, the strategic and synergic long-term partnerships. Long-term is the key issue. Now, we tried always to practice this building block, we call a building block of knowledge gain, to face all the technical challenges. At the base of pyramid, and the most important one, is to understand always the physics behind the core concepts. Then the use of a common benchmark model that closes the academy research to the industry reality. And at the top, we try to explore the interconnections among the disciplines, the cross-fertilization of the researcher, too important in this project. Another driver, the adoption of a research development with industrial consulting expertise. The acquisition of insights into new aircraft design. The evaluation of new practices in the aircraft design cycle as design strategies, how to use the information, disciplines and design requirements, model types and fidelities, solution types and sequences, what goes in the optimization cycle, optimization strategies, how to cycle, and verification strategies, what goes, or we have the need to go outside the optimization cycle. And another important point, the aircraft design absolutely should not be viewed as an automated process. Another driver, we stimulated along all this period the use of computational programming tools based on the practice and the costs of the industry. Very important. Using optimization looks like in the old times that we have started using finite element modeling. We didn't have enough computational power, so nowadays, as we are getting more digital, we need to challenge aerodynamics and aeroelasticity, considering the best methodologies with methods with competitive computational time, according to the design phase that we are working. So there is some interesting notes in the new ASM code, verification and validation code, that says that we have to use the model for the intended use. We have to apply the model for the intended use of it. So this is an important principle. So we have to challenge aerodynamics and elasticity to this to have computational times. The good enough for the phase that we are applying the technology. We also stimulate the improvement of interfaces with the structural FEM software used by the industry. It's important, we have our main software and we stimulated this, but it's important. Stimulation is something that does not close from the beginning the objectives. It opens and then closes, because we have to have stimulate this use in the academy. So another important point at this time of available computational tools, not try to include every discipline and always consider running things outside the optimization loop. It's important. And the last but not the least, the applications using the Embraer benchmark models. This is something that in the former project, a composite wing aeroelasticity, we try to experiment or test the ways we're going to have to work with the academy. And in the DD wing that we did with DLR and TU Delft, it was very nice that we realized what kind of information they need. And we built this idea of, together with this idea of Embraer benchmark models. Actually, the Embraer benchmark model serves as a common reference and research model for validating innovative design and analysis methods. We close the work of academic work to the industry. It was conceived as a generic aircraft with requirements like a regional transport airliner. It's a set of specification data, related finite element models, and results from optimization attempts. It's an evolving design with new features always in implementation. So these now you can see its wings that we call the Embraer benchmark wing. We have all models, even the aerodynamic models. So now, in terms of results, what you had? So for me, the most important result is the generation of knowledge. Most important one. Sometimes the companies, they take for granted knowledge, because when they do the research, they work with the institutions, and they always seem that it's easy to work together. This knowledge is always taken for granted. The knowledge that permeates along the institution is taken for granted, like we take for granted our health, and when we need it, we don't have it. So knowledge is the most important thing, both for academy and for ourselves in the company. So one of the important results was the successful outcomes of doctoral and postdoctoral research. I mapped 14 PhD theses sponsored and performed during the Aeroelastic Tailoring project. And they were sub-projects in the main topics of the first and second phases of the project. Technical papers, I mapped 46, and they were high quality and high impact publications. We did 8 internships at Embraer. Embraer used to, people from Embraer, engineers, they used to study outside. We thought this in a different way. We take inside our company researchers to work for a period of 3 months, 6 months with ourselves. Even Mario stayed more than 6 months. And the yearly workshops, 6 we sponsored together with the institutions. The workshops, they are 1 week yearly meetings with the following objectives. Report the progress made by every sub-project developed by each partner. Review the milestones achieved in the development. Expose the group of researchers and engineers to the other discipline problems, because the tailoring is truly multidisciplinary by its very nature. And most important one, build one team spirit in this diverse culturally group. We started, Professor Erasmo sponsored the first one in Italy in 2015. Then Professor Sun Ha in South Korea, in Seoul, 2016. 2017, we went to Delft, then Swansea in UK, and then we're gonna have the experience in Brazil, in the University of Minas Gerais, and in Embraer as well. I brought the group of researchers to know Embraer and visit Embraer. And after the pandemic, he started in Bristol. And we did this feedback online meeting, trying to have the feedback from the researchers 1 month after the meeting. It was something that was suggested by our new boss. And okay, in terms of technical papers, I list some of the most important publications and they were did, but it's important to point that during this ICAS in 2024, we had an Aeroelastic Tailoring session. 10 publications were approved inside our committee for release of publications in our R&D department in Embraer, and we brought here this and established this tailoring session. And it was nice because we opened these discussions to other researchers, and the experience was very nice from all the participants. So it's a good initiative to have this ICAS session in aeroelastic tailoring. So now, this is something that we have to do in the near future in order to get these digital twins and exploring the upper levels of the building block pyramid, the verification and validation. I would say that the mechanics of solids was the last one, the last community to adopt the or to standardize the finite element technology, I would say. And we were the first ones to use it, mid-70s, beginning of 80s. And we have to be careful because now we have to practice this digital, we have to practice the verification and validation. And we have a step up on this, trying to make our aeronautic industry less deterministic, more stochastic, like other industries. And I think this is going to be it's going to be, in terms of the certification authorities, very important. So, in terms of the verification of numerical models and experimental validation in the upper levels of the building block, we try to experiment the rapid prototyping, having quick wins and low budgets. So there is one example here. Oh, sorry. The panels buckling tests that we conducted in TU Delft with the support of Polytechnic de Torino and Embraer teams, with the objective to study wing configurations obtained with the application of the technology framework. This produced 8 publications. And from the Embraer side, we have now a framework for high-fidelity aeroelastic tailoring that is able to produce composite parts, feasible, manufacturable, and complied with Embraer design rules. And this was verified in a paper with the international review in AIAA, Journal of Aircraft. Our framework consists of two-step optimization. The first step, a gradient optimization, creating a directional stiffness map of the structure. And the second step, a discrete optimization that creates a tailored stacking sequence following design and manufacturing requirements. Another important project results from Embraer side, the internal applications through the joint activities with conception, preliminary, and detail design teams. It's very challenging to use optimization when you are applying at the detailed design, challenging the computational time. We have an improvement of Embraer knowledge in the aeroelastic tailoring technology through the sizing of aerospace structure applicable to all design phases as well. We did a lot of trades among structural concepts, and we are able to do these composite trades, for example, composite versus aluminum, new topological concepts and everything, and insights into technological gains. During all these years, since the first project, Composite Wing Aeroelasticity, we had 12 courses in Embraer, seminars and lectures. The courses were done by our researchers, and sometimes we invited external researchers or even the participation of students in the courses that were, the students, university students in the courses that were doing in Embraer. And this started since the first composite wing elasticity project. So, and we had one internship, we are going to have one internship in the Research Institute. So some courses involved, as I said, the participation of the partnership researchers. We had an improvement of Embraer knowledge in composites, structures, materials, manufacturing process, dynamics, aeroelasticity, loads, quantification and propagation of uncertainties and variabilities, ground vibration testing, and experimental planning. So another important, so something that is indirect to this, to the tailoring, but we challenge a continuous improvement in our administrative, contracting services, cooperation, IP, internal services, processes, during all phases of the project. Because of the initiatives that we had in Embraer, and we were not used to it, we challenged all these, and we are improving our response to these challenges. And another important internal result was the creation of an Embraer Technological R&D Internal Publications Committee that checks and approves external publications of research with Embraer partners. So, I would say that concluding the Aeroelastic Tailoring project has been promoting and encouraging long-term aeronautical research and technology at the global level, providing a unique way of cooperating with industry expertise. We have been producing high-quality work from a worldwide research community, 13 international partners, indirect partners, covering many aspects of the aeronautic science and technology. The project results show successful outcomes in generation of knowledge, in the research community, and also in Embraer, including indirect benefits, like I said, opportunities to improve our internal administrative process due to the variety of innovative initiatives. So, and these are the group and the teams of professors that have worked with us. These are real partners, and I'm here talking about them, our work together, and I ask these partners and the ones that are here in this lecture to stand up and to show yourselves. Please. And now I invite Professor Erasmo as a research representative to give the feedback of some of our researchers. And all this feedback this feedback was presented in a formal paper that we released for this institution. So, Professor.
Thank you very much, Pedro. So, I'm very happy to read some comments made by the other colleagues working on this project. But first I want to say a couple of things. You said that this project is unique, and this is for me, from my experience, is really unique because it's funded by Embraer. It's an open project, that started about 10 years ago, and we are continuously working. We never apply for a call. We never have the stress to produce a report. And so we are free to work, and we are also free to get new people in. And sometimes we really see if some expertise is missing into the group, and we try to get this expertise in. And this is also kind of a generosity which we have from all the colleagues. For instance, we came in because Professor Banerjee, somehow told you that we could be of some help in modeling composites. And it's also unique because I'm also not aware about a project like this from other big players in aeronautics. Of course, we say Boeing, Airbus, and then probably Embraer, right? And they are working on a more complicated part of the of aircraft, because regional is very competitive. They would like to go to composite, but from financial point of view, it's not easy because you don't know if you can really, work with a composite aircraft. Probably the others can do it, then can change, can build a 380, then someone else can do a 787, and then you do 340, then 380 disappears. But you can stay there, but for Embraer it will be difficult to stay there if something is. But so they are prepared with this project to go to composite. That's the main interest, I think, for Embraer. And it's also nice to see that it's coming from South America, yes, and they are probably the only player in that area, such a big expertise, and they were the ones that were looking from all over the world expertise. And if you've seen, Pedro has shown you that people are coming from all the continents, and we have also so many times invited scientists from the United States to come in our workshop and give their own opinion. But this is a sentence I wrote with Alfonso. It was also the place to make people growing up. Alfonso came to this project working with Professor Banerjee as a PhD student. Now he's full professor. In the meantime, he also got a ERC grant. So that's quality also, and was mostly involved in this project. And this is, we can tell story like the one of Alfonso for many others. And this is really something that we really like about the project. So that's unique. Okay, so I have some word from other colleague from Ranjan. I think he will tell me much better than me. He's one that really is extraordinary way to explain things, and we enjoy every time to have him with us. And this is you see the keywords has been put in green by Pedro. According to his, feeling, the most important words is unification and cross-fertilization. Then we have from Jonathan Cooper from Bristol, this great work and collaboration for many years, also for the future. And Professor Alberto Pirrera from Bristol, and he will say that he really didn't feel to the pressure working on this project and freedom to do things and to propose and to discuss, so new ideas without any barriers. Then Johannes Dillinger from DLR is also, underlining the interconnection among the disciplines. That's aeroelasticity, right? And the benchmark model was really something also unique for us, and we are, as people from university, we had the possibility to see really what are the constraints that Embraer puts in building the wings. And this was really wonderful. And from Roland, from TU Delft, created an environment where we can learn from each other. And this was really, really the case. And from Sunga, from Korea, as a project is, we found it extremely efficient, probably because of not so many constraints in it. So the freedom sometimes, you know, working with freedom is more convenient and more efficient than working without freedom, right? And from Gregorius Dimatris from Belgium, and you see so many things to underline: highest quality, publication and conference presentation, early progress workshop, are of international conference quality, and innovation, application potential, and is immediate and then most rewarding collaborative research activities as work with. And that's all. So thank you, Pedro, for giving me a chance to say something.
Okay, so these are the feedback from our researchers, and we have our director here. If you may say any words, Clayton. So I would say that this was possible because our support from our leaders, from our technical leaders. Along these 14 years, we had a lot. And I give you the privilege.
No, I think for me, it's an honor to be knowing more about this work. I was not involved in the previous years. But it's very impressive, the network that you build over the years, and fostered a huge collaboration among different partners from different universities. And this is something that I truly believe. If we have a common model, a common reference model, a real problem that we are trying to solve, and we can share openly between ourselves and try to gather different perspectives and different, maybe even technical background from each group, and try to come out as a solution, we are more prepared to have better and better solutions. So I think it is impressive, the network that was built over the years, and to maintain this network alive for several years, it's a huge and truly remarkable feat. And I congratulate you all for doing this work. Okay, thank you, Pedro.
And I have to give special thanks also to Mauro Kamiyama, one of my first colleague when I started working in finite element modeling, and he was the mentor of all these aeronautic projects in order to address our needs. Also to Gustavo Silva. Dr. Gustavo was a colleague during the composite wing aeroelasticity and the first phases of aeroelastic tailoring. Thank you, Gustavo. And I want now to show the small group that we are now. Please stand, Alex and Henrique. This is our small group that worked for all these years. We are missing Bruna, a new colleague that is working with ourselves as well. So that's it. We're gonna try to build composite wings like these ones that we have on these pictures. Thank you.
So we're going to have opportunity for some Q&A before we award the prize. So let's see if there are any questions, and there are people with microphones running around. You can just raise your hand, and please, when you ask a question, if you can introduce yourself and your affiliation. getting disappointed here. 4 days were too many. There's a banquet tonight. There is dessert. You know, you can perk up. Let's see a question. Carlos, yes. Carlos. Dr. Sesnik, you have a question? You're very happy.
And Godspeed continuing it. We need more of those.
You have a very friendly audience, you know.
Yeah, hopefully.
All right. Hello, you have a question?
Okay. Okay, a question from someone who has been part of this framework, that is, what is the thing that you have most enjoyed and has been most valuable since you started from the first phase? And also, what is that you would like to see in the future in this kind of cooperation that maybe has been a little bit missing?
Okay. Thank you, Francesco, for the question. So, it was very tough to keep this cooperation going on all these years. What I most enjoyed is how we build together these things. The ideas were not from the scratch, from a brilliant idea that we had for this. We built this together. This is what enjoyed me so much. But it was hard work to convince internally that we could do this work. So the most thing something that I want is to keep doing this as a long term, you know. But this is important to know, to say something that in terms of cooperation, we do not have budgets like the big OEMs. Embraer was always driven by smart, low budget, low result, big results with low budget. So it's we have priorities there as well. So for me, the most challenge is to maintain this for a long term. This is the most challenge. So I think it is. That's it. Thank you, Francesco.
Okay, there's one more question down there.
Matthias Meusen, Airbus Future Projects. Congratulations, a very impressive achievement and a very interesting approach and result. How did you manage this fine line in a academic cooperation over this long time between sharing know-how, integrating capabilities, and separating that from your sometimes quite competitive business?
Oh, this is a good question. It's from experience that I saw, for example, I have seen the cooperation between GE and Safran, a long-term cooperation, and they are main competitors. And we could work together. Like this is an example that we see in the industry. They are main competitors and they work together. Why not doing this between partners that work for other competitors and ourselves? We find ways. It was the main problem that I have to convince inside the company to do this work, you see. And we are not used to this, you know. Embraer used to go to the congresses and he didn't use to present and just listen. So we changed slightly our minds to have more proactivity in for these situations, you see. But it's usual, you see. This is usual, and so I truly believe that we can do cooperation even if you are competitors. You see, I think it's something that I truly believe it is.
So obviously this is a very big team, and I'm very concerned that they're going to fight amongst themselves. Who's going to get this? So we're giving you the biggest medallion we can come up with. So it is very heavy. Please do not melt it and divide it. I don't want to see it on eBay either. I think it makes a lot of sense, since this is a collaboration award, that all your colleagues come here on stage so you can take this picture all together. So if the collaborators would like to come up on stage, we can have the photographer take a picture with all of you. Okay? Congratulations again on your accomplishment.
Oh, hold on.
Yes. To see the picture, yeah, it's big. Yeah.
It's Oscar.
You can make a copy of that.
That's right. Very nice. Very nice. It's quite cheap.
Yeah. And a certificate for you to remember this day. Welcome. Congratulations. Is this your computer? No. Okay. Oh, just the paper.
Okay, I will.
You take it. Okay. Thank you. As a gift for you. This is yours, right? All right, we're getting close to the closing ceremonies here.